Good afternoon, everyone. Welcome to Great Learning's Project Showcase Day for our postgraduate programs in Artificial Intelligence and Machine Learning and Artificial Intelligence for Leaders. My name is Harish Subramanian. I'm a program director for these programs. And we have a wonderful afternoon in store for you. We go through a number of really inspiring capstone projects, and what these capstone projects are, Dr. Abhinanda Sarkar will talk to you in a moment, but these are very intensive projects that our learners do as part of our postgraduate program in AI, machine learning, as well as AI for leaders. And what we've done today is put together some of these projects. This is not to say that the work of everybody else isn't as good. We are constrained by just a few slots that we have, but we wanted to give you a taste of some of the fantastic work that our learners are doing here at Great Learning through these programs, and a taste of just the degree of practicality and applicability of the kind of learning that our learners are going through the course of these programs. In a short space of anywhere between 6 months to a year, our learners go from not knowing anything to doing some truly remarkable work, things that have been published in journals, things that have been, as you'll see now, things that are worthy of becoming companies and products unto themselves. So that's the exciting world of projects that we want to share with you today. As I said, my name is Harish Subramanian. I'm a program director here at Great Learning. I have a background in AI and machine learning myself. I did my master's in what is now machine learning from the University of Texas at Austin, applied it in the industry in the service of financial services and companies in the trading and hedge fund area. I also have a background in management consulting at the Boston Consulting Group. And now I lead all of our new initiatives and new programs, specifically a huge emphasis on our AI vertical and our AI programs over the last couple of years. More importantly, let me introduce Dr. Abhinanda Sarkar. Dr. Abhinanda Sarkar is the pillar on which these programs rests. Dr. Abhinanda Sarkar, as an academic director at Great Learning, has he teaches, he leads some of these projects, and he helps design and make sure that everything we do, all our programs, are truly cutting edge, world class, and things that we can truly be proud of. Dr. Abhinanda Sarkar has a fantastic pedigree. He has a background. He has a PhD from Stanford. He's been educated at the Indian Statistical Institute as well, and his professional career spans both industry. He's worked at stellar companies like GE, IBM Research, and so on, as well as teaching. He has taught at places like MIT. And now we're very fortunate to have Dr. Abhinanda Sarkar lead our initiatives, right? And we're doing something truly innovative and truly something that we're truly proud of. And the projects that we're here to present represents all of the great work that not only Dr. Abhinanda Sarkar is doing in leading these programs, but also all the fantastic and hard work that our learners are putting in. Over to you, Dr. Sarkar.
Thank you, Harish, and welcome to all of you. So as Harish said, my name is Abhinanda, and we're going to go through a very interesting journey today, not just on this session that we're doing for about half an hour or so, but for the sessions that are to come. So we'll be talking about a number of very fascinating projects, and these projects are from all over the place, as you'll see. I'll talk a little bit about each of them. I'll give you a context for what these projects are trying to do. And I'll talk about capstone projects in general. What they're like, what they're supposed to do, what our learners learn from them, and what we hope that future projects will be about, and all of that. And of course, given the media that we're on, we solicit your feedbacks, either at this time or in other media, etc. And we look forward to seeing you in some capacity soon. Now, the projects that we will be talking about are spread over half an hour modules, and they will be on different forums on these channels. And I absolutely urge you to log on to those particular channels and see the ones that are of interest to you. There are titles associated with each of them, like motor insurance accident assist, which is what we'll be beginning with, COVID and X-ray detection, COVID detection using X-rays. IPL, we're just about to have another very exciting version of IPL. Can we do some prediction regarding that? Can we figure out how to make our homes safer using intruder alert systems? This obviously is a time and age for seeking new jobs and new opportunities. Can AI itself help out in doing that? And of course, can we deal with interesting kinds of data? For example, handwriting, and figure out what to do with forms of information that we were not familiar with in the past. Which leads me to saying that what are these projects about and what kind of technologies are involved? And what does a capstone project actually tend to do? And what I want to do is I want to take certain snapshots from these projects themselves and take you through the journey of a project, or take you through an AI life cycle in some way, and what it means to execute on this kind of technology. And I want to divide that into 3 pieces. You'll see what those 3 pieces are in due course in time. But let me begin with the first one. So the first one, like anything, is data. Now, a question that's often asked is that what's so new about this machine learning world and the AI world? We've been doing statistics and database for a long time. Why is this suddenly of interest, and why the technology spurt around it? And why should I do this program, and why should I do these projects? One main reason for doing it is the kind of data that we deal with. For example, if I'm talking about 12/02/2019, this is a date. In a previous day, this day and age, this would simply be a number, and I would put it into a database, date, month, time, etc. Today it doesn't need to be. Today it can be handwriting. Today it can be somebody's job to just write it down by hand, and a computer's job to try and understand, how do I digitize that? How do I convert that into something that an algorithm can run on? Imagine the power of that. The power of that is that now the world of data has expanded hugely to saying it's not just about numbers in a computer. It's about making something else that the human eye understands as a concept, as information. But now we have the ability to make a computer understand that. So that's the first kind of thing projects and capstone projects tend to do. They tend to work with interesting new forms of data. Now, these can be, to some extent, pictures like I show here, and that those can be pixelated, like 78 pixels, which is a very clinical, mathematical way of saying that this is an image, and those images are 1 and 2. But they can also be words directly. They can also be things that are spoken or things that are written. For example, if I'm looking and scanning over resumes, which is what another of our projects is doing, how do I understand what a resume is? After all, it's just a bunch of words. How do I aggregate that information on words into something on which I can do intelligence? So I can do that in various ways, and you'll see the project do that in different ways. But at the base of it is the ability to extract from that resume, from those documents, words that mean things. This, for example, is an example of what's called a word cloud, which tells you that these are the words. And some of those words occur more often, some of those words occur in more documents or more times in a given document. And so this kind of information now becomes extremely powerful. So the first part of a capstone project is usually some understanding of the data that it deals with. And this is particularly what makes it AI. Because the ability to create data that doesn't look like data, it looks like pictures and video and speech and text, and to convert that into data using various kinds of software and various kinds of technologies that are available is usually where a project begins. Because without this data, there isn't much you can do. And with this kind of exciting data, there's a lot that you can do. Now, what happens after that? What happens after you've sort of figured out that there is data? After that, what you do is learning. Learning, of course, for a human being means that, you teach me something, I teach my daughter, say, it's addition and subtraction or ABCD, etc. Here, we're teaching a computer how to learn. And teaching a computer means programming it. Programming it to say, okay, understand the logic behind this and encode it in a certain form. For example, let's suppose that I'm trying to get chest images and I'm trying to get images and have those images tell me whether the person has COVID or not. COVID, as we know, is a respiratory illness. It affects the lungs. And so can a lung image tell us about that? And you'll see that in one of the projects that's coming up. But how do we make a computer learn such a complicated thing? And this is where the next great innovation, so to speak, of AI is coming in. Not just about new forms of data, but about new sophisticated forms of learning. These are sometimes called deep learning. Deep in the sense that we have input and then we have output. An input may be an image and an output may be a diagnosis, COVID positive or COVID negative. But in between, there are lots and lots of layers. We teach about these layers in the AIML program, for example. My colleague Mukesh Rao is an expert at this, and he teaches this wonderfully across the programs to say that this is what deep learning is. This is what this complicated looking architecture means. This is called a convolutional neural network. But these kinds of networks come with their challenges. They come with being able to understand what this network does. And here, let me tell you a secret. Nobody knows what they do. We know they work well, but we don't know why they work well. So we don't quite know what it is that we need to do to a network like this, doing things like convolutions and pooling and such sophisticated things to make it work. So in a project, you have to work very, very hard to be able to tune the algorithm, to be able to tune an algorithm to say, okay, how do I fiddle around with the various knobs in it to say that this will work? And so this part of a project usually ends up just playing around with these kinds of algorithms, playing around with these networks and topologies or whatever you want to call them, and then figuring out what version of it will work. What settings, how many of these layers do I need? How many samples images should I pass in at a time? How many do I need to train, as it is called? That is, in order to teach the network, teach the algorithm how to understand COVID positive or negative. And projects spend a lot of time doing this tuning. Now, this tuning doesn't necessarily have to deal only with, shall we say, a single concept. Different kinds of tuning work with different kinds of concepts. Another project, for example, deals with home security, looking at intruders. And trying to understand from their faces, is this someone who should be there? Is Abhinanda supposed to be there, or is he in the wrong place at the wrong time? So how do we figure that out? How do we tune an algorithm? So the big thing about this is that this is not just the work of the project. There are lots of other projects and lots of other algorithms and lots of other ideas that have already gone out there. And so these kinds of implementations that others have done help in starting projects on their journey. Set algorithms, for example, like FaceNet, would help initiate and say that, okay, let's begin here. So therefore, our learners and those who are doing these Capstone projects do not begin with an entirely blank slate. They begin with these networks and they begin with these kinds of implementations that are there that help tune what these algorithms are going to be like. And so doing deep learning and then tuning it, I mentioned my colleague Mukesh Rao and the other faculty as well, help, and our mentors help in taking them through this journey to understand the technology that is there, to strip away the math behind it, leave the code, and then to manage the code in a way that gives good results. This is in some way the middle part of the project, and this is in some way the most exciting part of the project, so to speak. But what happens to these projects at the end? They need to live. They need to live in the real world. They need to have impact. And when we talk about impact, there are two kinds of impacts that we need to ensure. Number one, we need to ensure that all the various things that we have done, of all the different kinds of neural networks and models and algorithms that we have built and that the projects build, which one should we take? Which one works? Which one is a sensible thing to take to people? And from a project perspective, they say, which one do I report? And so one way to do that is to compare models and to look at things like LSTM, long short-term modeling, GRU, gated recurrence networks, and various kinds of networks that are there, random forest, support vector classifiers. Our learners go wild, enjoying themselves building these models in these projects. But then we wrap it back. Wrap it back and say, okay, you've done all this. Now tell me what works. Tell me what works. Tell me what works by saying, how good are you? How precise are you? Can you find what you're supposed to find? Can you recall what you're supposed to recall? Can you get the right diagnosis? Can you get it for all the right images? Are positive people actually diagnosed as positive and vice versa? And you can keep doing this at different stages of the project. For example, I'm showing this for cricket prediction. And this is what is happening at the end of 5 overs. So at the end of 5 overs, you can figure out which model is a good model to say what your prediction is. And you can build wonderful systems like that that say that given all this plethora of technology, bunches and bunches of technology, then how is it that I can get the right output simply put so that you understand it and that you don't have to be a machine learning expert in order to predict what's happening to the IPM. The other kind of output is if I make a product out of this, if I make it live in the real world, will anyone pay for it? Will it be a business? Will it be something that makes somebody better off? Is there a business model around this? Is there some reason to believe that this makes somebody's life better in a tangible way? In a business setting where many of our learners come from, it means, is this a commercial product? For example, will somebody pay for better insurance if I build an assisted insurance product that will tell me that this is more information about the accident? What is the business story around that? How much money can be made around it? Who will buy such a thing? That's important. And our AIFL program, for example, educates our learners in order to be able to do that. And Capstone projects there tend to focus on, shall we say, the business end of technology. So I've talked about all 6 of our projects and you'll get many more details. I do not want to leave you with the impression that 2 of our projects will talk about data and 2 about models and 2 about end use. No, they'll all talk about their own journeys. And they all will show you what they have learned, what innovations that they have made. Of course, as Harish has said, these are not the only projects and the only programs that we have. We have hundreds of them, literally, across the various batches. We have a set of projects coming out on a monthly basis across our programs. And so, for example, what happens to all the other projects? Exciting things happen to them. A couple of honorable mentions. For example, one project on Airbnb. This was submitted to a conference recently at the Institute of Management in Bangalore. Dr. Narayana, who is one of our faculty members and mentors in this, was interested in this. And one of the best things that can happen to a project is to get Dr. Narayana's interest. Because what he does is he takes these ideas and then he puts the rigor around it. And he says, this is now worthy for me to talk to other people about and to write papers about it and to get it into print and publication. So as I said, for our best projects, get Dr. Narayana's attention and the attention of the rest of the faculty. And then we can bring it to this kind of logical output and bring prominence, not just to the people who did the project, but also to the technology itself. And if that is what interests you in getting your name out there, go for it. It may not interest you. What may interest you is, hey, I want to see this implemented in my company. Well, many of our projects do that. For example, in the banking industry, we've had projects for signature verification. Tough problem. I'm signing. Am I the real person? Even if I do not do it on a pad, on a computer, it still needs to match. Can AI help in being able to do that? And if it works, you bet a bank is going to use that. Nobody would want to take a risk on saying, I got the wrong signature and give away a few lakhs to someone who didn't want it. But for me to use that project better be good. Because I also do not want a genuine customer to come back and complain, you didn't clear my check. So neither way, the errors are bad. If I can fix it with a good project and the bank says, okay, this is good and it's real, it works, put it in my bank, give it to my real customers. And many of our projects do that. As we said, here is an example of one. So we've got many of these projects and they go through these journeys of understanding the information and the data that they use, playing around with all kinds of technologies and all kinds of models, and then translating them into some form of reality. And they go through these steps. Along the way, we've learned many things as we do this in the project. And to figure out what it means, for example, what it means in practice. What have we learned from all of this? What have our projects learned? And so, for example, my colleague Mohita, she's been teaching me some of this stuff for the last 2 years. She says that whenever you talk about this, you've got to talk about what makes these things real. And Mohita and our learning about this is that there are things that we need to keep in mind, and our learners have found that out as they do these projects. Number one, on the data side, make sure that the data is, shall we say, good. In particular, that it has no bias. For example, if you're looking at images, are all the images of one particular kind of patient? In which case the algorithm will be biased towards that kind of patient and will work only for that kind of patient. Does data have bias of that kind? Is data honest for the application that I want it to be used for? The fact that data is easy to collect doesn't mean that it is the right data to collect. And some of our projects have found that out by using easy data and getting not very good results, and working to get good data and getting much better results. And then, of course, on learning, or as we say in machine learning terms, training a model. Spend some time in understanding how that model is trained, how that model is going to build itself. Give yourself enough time to play. Not to do this towards the end or just give itself a little bit of time, but if you've got to tune a model, tweak it, tender loving care, how does it work? It's like grooming a cat. So make sure that it's okay. And that takes time and has to be done with a certain amount of tender loving care. And those projects to do that well come out with good outcomes. And so our projects have learned how to do that, to spend their time appropriately in building the right kind of model. And then, of course, when it comes to implementation, to see that let all this work that I've done, let's say over 3 months, 5 months, put it all together and say, this is the best thing. And maybe the best thing was the best model that I got 2 months ago. And all the other work that I did was exciting, but nothing beat what I did 2 months ago. So maintain all the versions of the models, maintain a record of what you have done. The journey is important. Remember the journey. And projects that remember the journey well succeed because they say, this is actually very good. It's simple, but it's nice. A simple linear regression got me very good, understandable output. So maintain versions of the data and maintain versions of the model. And at the end, don't come up with what you ended with, but come up with the best. And our learners have learned that over time. So we've learned so many wonderful things in the course of this journey. My colleagues and I mentioned a few of my colleagues, but there are many others who manage the program, who manage the projects. And of course, there are all our learners who come from so many different places and have so many different interests in doing these projects. They come, they communicate with each other, they learn new things. Today morning, I was in a project in which people were saying that, oh, this is a doctor and who's helping build a prognostic system for industry. Is there something wrong with the lubricant in a steel mill? Things like that. So they learn, and in the process of a project, they crystallize that learning. And that is what helps them. Not just the technology, but the different kinds of things that go into it, different kinds of data, different kinds of model, different kinds of implementation styles. So as the projects come up, they're going to come up in different sessions. Please do click the link. Please do listen to all of them. We have kept their original material, their original slides. They will present it as they feel, as they think is appropriate. We have guided it, but you are hearing it and going to hear it from the words of and the faces and the material of the people who've built this out. See their journey, and I hope if you are already with us, enjoy what your own work product. If you're not, please learn from it. And if you're looking to join us in the future, then we hope to see you and hope to see a project like this and possibly even better from you as it comes aboard. And for the rest of you, who've done projects as well, and we have shown we have not forgotten. We're all on the journey. We're all on this great learning journey together. Today, it's project time. And for the next 3 hours or so, go and see what we have done. This is our showcase. Have a great afternoon, and I'll see you around somewhere.